This is the Collatz Conjecture, a problem which, although simple to understand, has proven near impossible to solve. So much so that famous mathematician Paul Erdős once said, "Mathematics is not yet ripe enough for such questions." This conjecture goes as follows. This process will reach the number 1 regardless of which positive integer is chosen initially. There are 2 rules for this problem. Number 1, if you have an odd number, multiply it by 3 and add 1. And number 2, if you have an even number, divide by 2. To explain this, pick any positive number that is whole. 3, alright. As 3 is an odd number, we multiply it by 3 and then add 1. So we get 10. 10 is even, so we divide by 2. 5, that's odd, so times by 3 and add 1. 16, then 8, then 4, then 2, then 1, then 4, then 2, then 1. At this point, an infinite loop is entered. The creation of this problem is generally attributed to Lothar Collatz in 1937. Although the problem is also known by a variety of other names with their respective creators, the problem is probably most commonly known as the 3n plus 1 problem. Every single odd number when multiplied by 3 is an odd number, plus 1 and it becomes an even number, which is immediately divided by 2. This means that in all actuality, an odd number can only ever really grow by a factor of approximately 3/2. Let's look at the number 1365 for an example. If you multiply it by 3, then add 1, you get 4096. So divide by 2, 2048. Divide again, and 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 again, leaving us right back at the 4-2-1 loop. There are 2 ways the conjecture could be proven false. The first would be to find a sequence that for whatever reason climbs to infinity, a sequence that never crashes back down as all others have. The second way to disprove the theory would be to find a completely separate closed loop, other than 4-2-1. Up to this point, no one has been able to find a sequence that complies with either of the previously stated options, despite the fact that mathematicians by brute force have tested every single number up to 2 to the 68, or 295 quintillion, 147 quadrillion, 905 trillion, 179 billion, 352,825,856. However, on the scale of infinity, 2 to the 68 is a pitifully small number, meaning unless some new creative way is found to either prove the conjecture true or false, there is a chance it will never be solved. Thanks for watching the video, all sources will be listed below.